Charlie is building an ice cream sundae at Isabella's Impressive Ice Cream. There are 4 different flavors of ice cream and 7 different toppings from which he can choose. He can choose any whole number of toppings and ice cream flavors, but he must have at least 1 flavor of ice cream and at least 1 topping. And given that the order in which he chooses the ice cream flavors and the toppings does not matter, we want to find how many different sundaes can Charlie make. All right. So first, when we start this question, I just want you to imagine like your parents taking you to your favorite ice cream place, right? And they have 4 flavors. Let's just say they have vanilla, they have chocolate, they have strawberry, and then what's a 4th flavor? They have mint. All right. And then your parents tell you, oh, you can choose anything you want. You can choose as many flavors as you want, whichever ones you want. So what you would do is you would look at the flavors one by one. You would say, oh, do I want vanilla? Yes or no, right? So there's 2 options here. And then would I like chocolate? Yes or no. And then would I like strawberry? Yes or no. And then would I like mint? Yes or no. So if you were free to choose anything you wanted, you would have 2 choices for each of these flavors. And then, so that means we'd want to multiply all these together to get the total number of combinations. And we're just talking about the flavors, by the way. And this gives you a total of 16 combinations. However, we want to make sure you get something, right? It would be weird if you said no to every single flavor, or else like, why would you be at the ice cream store in the first place? So we want to make sure we subtract out the case in which we choose no for every one of these flavors. And then this gives us 15 ways to choose any number of flavors that we want. And then we notice that we can just do the same exact thing, but for the ice cream toppings. So instead of listing 7 toppings, you can try and like think about what the number will be. So let's just say we have like 7 toppings, numbered 1, 2, 3, 4, 5, 6, 7. And then same with the flavors. We can either include a topping or we can not include it. So we have 2 choices for every single one of these toppings. And then if we multiply all these together, this might be a lot of multiplication, but we should get that there are that 2 times 2 times 2 times 2 times 2 times 7 times will give us 128. And then once again, the question says that we must choose at least 1 topping. So we can't choose all no, so we have to remove that case again. And this gives you 127 possibilities for the flavors. For the toppings, sorry. And then if we want to find how many combinations of ice cream flavors plus toppings, we would multiply these 2 numbers together. So our final answer would be 15 times 127. And then if we do the math, I believe we should get 1,905. And that perfectly lines up with our answer choice B. So I think the main takeaway from this question is it might be hard at first to think how to count like any combination of 4 flavors, right? But if we consider each flavor individually, like vanilla, you can either want it or you don't. Let's say you're not feeling vanilla today, but you really want chocolate. So you can choose chocolate. You can say no to vanilla, yes to chocolate, like yes to strawberry, and no to mint, right? So that's one of our possibilities here. So there's the main takeaway is we have 2 choices per possibility, and then it's really important that we subtract out the case where you get nothing. And yeah, that is the main takeaway of this question.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.